Hi, today we are learning about terminating and repeating decimals. Let's look at the word terminating. The key word in terminating is terminate. And what does terminate mean? It means something that ends or finishes, like the Terminator, right? The Terminator terminated other people's lives. He finished them, he ended them. So something that terminates is something that ends. And repeating, we know, is, for example, if 27 repeats over and over and over and over, that pattern is repeating, right? So we are going to apply these terms to decimals. Alberto plays baseball for the Piney Creek Wildcats. In his first 30 times at bat, he gets 10 hits. Write his batting average as a decimal. So first let's write what his batting average is. He gets 10 hits out of 30 attempts. So 10 hits out of 30 attempts, right? And so now let's try to turn it into a decimal. And how do we do that? Bottom into top. So we do 30 into 10. Now 30 can't go into 10, so we have to add a 0, which means we have to add a decimal up top. 30 into 100 is 3 times. 30 times 3 is 90, which leaves us with a remainder of 10. And 30 can't go into 10, so we have to add another 0. And 30 into 100 again is 3, which again leaves us with 90 and a remainder of 10. As you can see, this decimal is going to keep on going forever and ever and ever and ever and ever. It's never going to end. And this is what's called a repeating decimal, because the 3 is repeating forever. It's never going to end. Therefore, Alberto's batting average is 0.3333, or if we want to round it to the nearest thousandth, that would be 0.333. Every fraction can be renamed as either a terminating decimal or a repeating decimal. A terminating decimal ends somewhere. Remember, terminating or terminate means to end or finish. So, for example, if we have 5/8 and we want to turn this into decimal, we do 8 into 5, add a 0, add a decimal. 6 times 8 is 48 with a remainder of 2. We have to bring a 0 down. 8 into 20 goes in 2 times. 16 with a remainder of 4. Bring down the 0 again. And 8 into 40 is 5. So this is a terminating decimal because it ends somewhere, right? It ends at the 5, because after this, it just stops. There's nothing left. Now, a repeating decimal has one or more digits that repeat indefinitely, or basically for a really long time, like we don't know how long. So when you divide, the remainder is never 0. Let's look at the fraction 3/11. If we want to make 3/11ths into a decimal, we have to divide the bottom into top. So 11 into 3. 11 can't go into 3, so we add the 0 and the decimal. 11 into 30 is 2, and that gives us 22 with a remainder of 8. And 11 can't go into 8, so we bring down another 0. 11 into 80 goes in 7 times, and 11 times 7 is 77, with a remainder of 3. 11 can't go into 3, so we bring down another 0. 11 into 30 again goes in twice. I think you see where we're going with this. 11 times 2 is 22. And again, we have a remainder of 8. Bring down a 0, and it's just going to keep going. So it's going to keep repeating 0.27, 27, 27, 27 for who knows how long, forever, right? Because it's never going to stop. And this is an example of a repeating decimal because 27 is repeating over and over. Since 0.27272727 is very different from just 0.27, there needs to be a way for us to tell people that the 0.27 repeats. So when you have a repeating decimal, such as this one over here, how we write it is 0.27 with the bar over 27 because that's what's repeating. So in the previous example, 0.3 was repeating 3 forever. So we can write it as 0.3 with the bar over, and that lets us know that in this case the 27 is repeating, and in this case the 3 is repeating for forever. But remember that you're only putting the bar over the parts that repeat. So if you have 5.13636 and it goes on and on and on, what you're going to put the bar over is just 5.136 like this. So the bar only goes over the part that's repeating, which in this case is the 36. If we have to rewrite each of the following repeating decimals with a bar over the part that repeats, this first example is going to look like 0.6, the bar over the 6. And in the second example, 0.8333 forever is going to be 0.83 with the bar only over the 3. And if we wanted to expand these decimals that have the bar over them to, let's say, 4 decimal places, we could turn this into 0.1212 and this one into 0.1, but notice the bar is only over the 4, so 444. Not too bad, right? Let's rename each fraction as a decimal and state whether it's terminating or repeating. 1 over 8, we know that we have to do bottom into top, so we do 8 into 1. 8 can't go into 1, so we have to add a 0 and then a decimal up top. 8 into 10 is 1, remainder 2, bring down a 0. 8 into 20 is 2, 16, remainder 4, bring down a 0. 8 into 40 is 5. So 1/8 is equal to 0.125. And since it ends, right, it is a terminating decimal. Now let's try 5 over 11. We have to do bottom into top. So we're doing 11 into 5. 11 can't go into 5, so we have to add a 0 and a decimal. 11 into 50 is 4 with a remainder of 6. And now we bring down a 0. 11 into 60 is 5. 11 times 5 is 55 with a remainder of 5. Bring down a 0. 11 into 50 again is 4. 44, remainder of 6. And 11 into 60 is 5. And as you can see, this is going to keep repeating. So this is a repeating decimal, and we write it as 0.45 bar. Try these problems on your own tonight for homework and bring them to class tomorrow for credit. If you're looking at number 4 a little confused, go back to the last lesson that we did where we worked with mixed numbers, turning them into decimals. Remember, all that you're really going to be working with is this 2/3 right here. You got this. I believe in you.